Welcome to this tutorial. This video is part of a video series from the ForzaETH F110 team from ETH Zurich, where we explain how you can start your own F110 journey from scratch using our videos. They are meant to accompany our open-sourced race stack, which won the F110 competition at the ICRA 2023 race. The GitHub page of the stack is linked down below in the video description. Furthermore, a full system paper describing all elements of our stack can be found as well in the description. Check it out if you are interested. This video will be about the software, meaning I will show in a step-by-step manner on how to install the ForzaETH Race Stack and how to use it. We will use a Docker environment, meaning you can run the stack from any OS. There exists both a version for ROS1 Noetic as well as ROS2 of the stack. In the first part of the video, I will show you how to do it with the ROS1 stack, and afterwards the procedure with the ROS2 version will be shown as well. We will start on the ForzaETH GitHub page, where you can find extensive tutorials for the installation and usage. We will use these tutorials in this video here as well. First, we will open the installation guide in a new tab, where all relevant information for the installation is listed. Let's have a look into the prerequisites. As we will see, the installations listed for ROS Noetic and the Catkin build tools are not needed for us, as this will be done automatically during the building of the image. We can therefore go to the Docker section and open the Docker guideline README. In this video, I will show you how to use the stack with the simulator, and the procedure will be very similar if you are doing it on the race car. It is also assumed that you are using an x86 platform. If you are using an ARM platform, you will just need to replace the x86 with ARM in every command. However, first we will need to install Docker on our machine. For this, we head to the official Docker documentation and navigate to the installation section. As we are using Ubuntu 22, we select Ubuntu and check if we are fulfilling the OS requirements. We then head to the installation methods, and in the following, we choose the installation method using the apt repository. For setting up the Docker repository, a chain of commands need to be executed. To simplify this process, we create a temporary bash script and paste the contents there. Subsequently, we make the script executable and afterwards we run it. Following, we install Docker on our machine using the provided command from the guide. In order to verify if everything is working as intended, we run the Hello World image. Running this image should give us the following output into the terminal. Further below, it is also shown how you could uninstall Docker in the future. But for us, everything worked fine, and therefore we head to the post installation. There we want to achieve that Docker can be run also without root privileges. This is important, as without it, only users with sudo privilege could use the Docker. To achieve this, we first need to create the Docker group, and then we add the current user to the group. To apply these changes, we need to log out and then log back in. To make sure that everything works, we can again run the Hello World image to verify that it now also runs without sudo. Lastly, if we want that Docker directly starts when booting our system, we need to enable these services in the system control of Linux. Now that we installed Docker, we can go back and continue on our tutorial on GitHub. So Docker is now runnable without sudo. But before we can build the Docker image in the next step, we first have to clone the ForzaETH Race Stack repo from GitHub into a folder which is on our system. In order to clone the repo, you have to use the recurse submodules flag. Using it, Git not only clones the main repository, but also initializes and clones all of its submodules recursively. After the cloning process, have now a look into your RayStack folder. It should look like the following. The next step now incorporates building the Docker image. Be aware that this process can easily take up to 45 minutes, depending on your internet speed and also your hardware. After successfully building the Docker image, now export the needed environment variables and build the simulator container. In the following, we need to adapt our folder structure such that it looks like in the guide. To achieve this, your current directory needs to be the Race Stack folder, and after this you can just paste the make directory command from the guide. If done correctly, the folder structure should look like this, where the cache folder is on the same level as the Race Stack. After completing that task, we'll now launch VS Code in order to access the Docker image of the Race Stack through a dev container. For this, install the dev container extension in the first step. Then open the RayStack folder. And then subsequently press the shortcut Ctrl, Shift and P and select dev containers, rebuild and reopen in container. The ROS1 environment will then open and automatically build the Catkin workspace. Note that we are now in the dev container environment and can use the race stack through it as if we would be natively running it in ROS1. Having completed this process, we've successfully executed the Docker image of the ForzaETH Race Stack within the dev container. To verify that everything is as it should be, we can go back to the guide on GitHub, where we find instructions to launch the base system and initiate time trials in simulation. When now opening a terminal in VS Code, we are automatically within the dev container environment and can launch our ROS1 commands from here. If all steps were followed correctly, RViz should open now, allowing you to observe the race car navigating the simulation environment. In the following, we will show the installation also for the ROS2 version of the ForzaETH Race Stack. In order to access the ROS2 version of the ForzaETH Race Stack, make sure that the branch ROS2 Humble is selected, as the ROS1 stack is on the main branch. Analogously to the ROS1 part, we will follow the provided readmes. Please be aware of the fact that the ForzaETH Race Stack was developed in ROS1 and that the ROS2 stack is significantly less tested and explored than the ROS1 version. Let's now start with installation. For this, we head to the separate installation guides. In a first step, we need to clone the repo, and we do this for the ROS2 Humble branch. So we create a new folder called F110 and open a terminal in there. We paste in the command and execute it. It should now look like the following. So next step, we have to check out this linked Docker file. There we have to adapt the argument based on if we want to use the sim or the nuke, which is referring to the race car. As we are using the sim in this tutorial, the parameter needs to be set to 1, which is already the case in this file, and therefore we don't have to change anything. In the following, I will show you analogously as we did for ROS1, the installation using the VS Code dev container, and so not the Docker container. It is similar what we did back then for ROS1. If you use an x86 platform, such as an Intel CPU, then use always the x86 keyword. Contrary, if you use an ARM, for example on NVIDIA Jetson, then use the keyword ARM. For the next step, Docker is assumed to be installed and runnable without sudo. This was already showcased in the ROS1 part of the tutorial. If you didn't do it yet, have a look there. The next part incorporates setting up the X forwarding. This is only necessary if you want to use the dev container in a remote machine, such as the race car. As we are showing in the tutorial, the installation of the sim on your local PC, this is not needed. I will still demonstrate what you would have to do. This step is necessary in order to forward graphical applications, such as RViz, correctly from the remote PC to your local PC. To perform this task, first open a terminal and then cd into the race stack folder. Afterwards, source this xof_setup bash file. Lastly, you have to print out the display variable. For me, it's the following one, since I do this locally. However, if done on a remote PC, it would be something along localhost. Now we have to create the described folder structure in order to cache the Colcon builds, whereas Colcon is the build system used in ROS2. The detailed structure is provided in this scheme. We essentially can cd again into our race stack folder and then execute the given make directory command. If done correctly, it should now look like this, where we have the cache folder on the same level as the race stack. For the next step, we proceed to build the container. In a terminal connected to the remote machine you want to use, move to the location of the race stack and build the Docker container with the compose command. As we're doing this locally with the sim, we don't necessarily have to be connected with this remote machine, and you can just execute the docker compose build command with x86. However, it is important to choose between the available image services, meaning between sim and nuke. To achieve this, we have to change the image attribute in the devcontainer.json file. We can find this file in Files by pressing Ctrl and H, which shows us the hidden files. We then enter the devcontainer folder and enter the devcontainer.json file. We check here on line 13 for the image, where we have to alter the keyword nuke into sim_x86. Finally, we can start the building process of the Docker image. Keep in mind that this process might take a while. Once we've built the image, we can now open VS Code. If you're doing the installation with the remote race car, SSH into the race car via the blue remote connection button on the bottom left. We now need to open the race stack folder and press afterwards reopen in container in order to enter our dev container ROS2 environment. This will start the installation process of the server, which takes a while for the first time. Now it can be observed that we are operating with ROS2 Humble inside the dev container. The following step is again only necessary if you are doing the installation on the remote race car. Open a terminal and export the display variable number. For this, display first your variable number and then export it. As said, we are doing it here only locally, and therefore we can skip this step. What could also be done is to additionally attach terminals from outside the dev container and VS Code that are still operating within the dev container environment. This is achieved by running the sec_doc.sh bash script in a terminal outside of the container, as shown here. With this, we finished the last step of the installation process. We will now start the time trials in the simulation in order to verify that everything is functioning as intended. We therefore open a terminal and perform colcon build. Subsequently, we also need to source the install/setup.bash file. We now head back to the readmes and open the stackmaster readme in the Getting Started section. First off, we need the base system. For this, copy over the command and adapt the following parameters. For the map name, you can choose out of any that are inside the stackmaster folder, such as this one. In the next parameter, we need to specify if we're using the sim, which we confirm by setting it to true. Lastly, for the utilized race car version, we also set it to sim. Additionally to the base system, we want to launch the time trials. For this command, the race car version is again sim. For the lookup table used by the system identification, we can choose any from inside the system identification/steering lookup/cfg folder. And lastly, the utilize control algorithm can be alternated between model and acceleration-based pursuit and pure pursuit. Launching both commands results in the opening of RViz and the race car driving on the circuit. That was it with the video. Thanks for watching and see you in the next video on our channel.